All right, welcome to this page of the notes. Now this one tends to be a little scary for Algebra 1 kids, even Algebra 2 kids when they're first getting into the year. Please, just here's my best advice. You're gonna look at this and you'll be like, whoa, there are no numbers in there. You're right, this is algebra. We substitute letters for numbers. Here's what I'll tell you. Treat the letters as if they're numbers. If you treat the letters like numbers, in most cases, you guys won't go wrong. So here's what I'm asking you to do. I have given you this formula. It is a formula because we're representing all of the unknowns with a symbol, and I'm asking you to solve for one of those particular symbols. In this case, I'm asking you to solve for B2. We got to get this guy right here all by himself. We're going to treat the letters as if they're numbers and get that B2 by itself. Here we go. The first thing I need to do, since I'm trying to get this B2 by itself, is I need to take care of this 1/2. Well, 1/2 simply means dividing by 2, which is exactly what you're shown. You're dividing by 2. Well, how do I undo division? Multiplication. We'll need to multiply both sides of this equation by 2. If I multiply 1/2 by 2, they cancel each other out. That'll leave me with a 2a on the other side. So here we go. My first step is going to be 2a is equal. The 1/2 is now gone because it is canceled with the 2. And I'm left with h multiplied by the quantity b1 plus b2. Again, we're trying to get this b2 right here all by itself. We need to isolate that guy. So the next thing I'm going to need to do is I'm going to need to get rid of this h. Well, just like if it were a number, you would notice I'm multiplying, right? This is multiplication between h and this quantity. How do you undo multiplication? Division. So if this were a number, you would divide both sides by the number. Treat h like it's a number, all right? If you're multiplying by h, divide both sides by h, you're good. So we'll divide both sides by h. Over here, the h's will cancel each other out. That'll leave me with b1 plus b2. I no longer need the grouping symbols because these are the only guys left on this side of the equal sign. I've moved everything else over, so this is all equal to 2a all over h. Well, once again, I need to get this b2 right here, this guy, all by himself. This is a positive b1. How do you undo addition? Well, I'm going to need to take this b1, subtract a b1 from both sides, and the b2 will be the only thing left. So let's subtract a b1 from this side. Property of equality says you got to do it from both sides, so I'll subtract a b1 over here as well. That's going to give me 2a over h minus b1 is equal to b2. We are almost done. One last convention in algebra is the unknown you're solving for. We like to put it on the right-hand side of the equal sign. No problem. We have a property of equality that deals with this. It's the symmetric property. We're just going to flip this guy. So I'm going to put the b2 over here on the right-hand side where we like it. That's all going to be equal to what was originally on the right-hand side. We'll now move to the left-hand side. 2a minus h. Sorry, 2a divided by h minus b1. The point here is if I give you letters or numbers, it doesn't matter. Treat the letters like numbers. You shouldn't have any trouble. Just to make sure, let's go ahead and try another one of these. So here's what I've got. I have another formula for you. Bunch of variables in there. We're going to solve for h. That guy right there. Okay, so I need to get him all by himself. Well, here's what I've got. I've got this 2 pi r squared kind of hanging out here in front. Let's move that first. Since it's a positive 2 pi r squared, the way you undo addition is subtraction. Don't forget to do it from both sides. Minus 2 pi r squared. If I do it to that side, I must do it to the other side. Minus 2 pi r squared. So here's what I'm left with. I now have an s minus 2 pi r squared, all equal to, these guys cancel each other out, positive 2 pi r squared minus 2 pi r squared, gone. I'm left with 2 pi h. Doing good, we're almost there. I need to get this h all by himself. How do I get that h all by himself? Well, please notice, I am multiplying the h by 2 and pi. Please don't waste your time by doing these one at a time, all right? Multiplying by 2, so you could divide both sides by 2. And then you'd be like, oh, well, I'm multiplying by pi, so I divide both sides by... do them all at the same time. Work smarter, not harder. I'm multiplying by 2 pi, divide both sides by 2 pi. We're going to kill 2 birds with 1 stone. We're going to do them all in the same step. Divide both sides by 2 pi. All right, here's what that gets me. That gets me s minus 2 pi r squared all over 2 pi is equal to h. I don't like that symmetric property. Flip it. H is equal to s minus 2 pi r squared all over 2 pi. Now, here's my question. Are we done? Is this as far as I can go? Because here's what I'm seeing. I see up here in the top, this term has a 2 pi in it. I see down here in the bottom, I have a 2 pi. Can I cancel this 2 pi with that 2 pi? Take a second. Think about what your answer would be, yes or no. Yes, I can cancel those, or no, I can't cancel those. If you're not quite sure, maybe pause the video, check with the person sitting next to you, or hop on the internet and Google it. Once you've come up with your answer, what we should see here is that you cannot cancel this 2 pi with this 2 pi, and here's the reason why. You should remember this from Algebra 1. You cannot cancel through addition or subtraction, and that's exactly what I have here. I have s minus 2 pi r squared. I cannot cancel those 2 pi's because of this minus sign right here. Here's what I could do. Let's just say, hypothetically, if I had this, if I had h is equal to s times 2 pi minus 2 pi r squared all over 2 pi. Well, here's what I would do if this is what I had. I would recognize, right? Because I still have this subtraction sign here, and that poses a problem. You can't cancel through addition and subtraction. But I do notice I have a 2 pi in the first term. I have a 2 pi in the second term. Since that factor is common to both terms, pull it out. I'll pull a 2 pi out of this s2 pi. That leaves me with just an s. I'll pull the 2 pi out of the minus 2 pi r squared, and I'm left with just a negative r squared. All of that is divided by 2 pi. This completely changes things. Please notice that right here, I now have multiplication. I have 2 pi multiplied by this quantity. You can cancel through multiplication and division, which means that these 2 pi's would cancel each other out. I would then be left with h equals s minus r squared. Right? That's if I had a 2 pi in this term. But since the answer that we got does not have a 2 pi here, you cannot cancel those 2 pi's. because of this subtraction sign right here. Do not cancel through addition and subtraction. You can only cancel if you're able to write it as multiplication or division, then cancellation would be okay. That takes care of this page of the notes. Head on over to the next page. I'll meet you there.